Hey Algebra. Today we're going to talk about target 1.7, which is using the rules of exponents to solve basic exponential equations. We're in our packet on page 29 right now, and we'll of course go through the warm-ups. You can do those on your own. And the idea here is we're using our rules of exponents to try to solve some equations. And some of these problems, they're really focused on the idea that if you have the same base, then the exponents, and you have two pieces of an equation, equal to each other. As long as they have the same base, they must have the same exponent. 3 to some power equals 3 to the 5th. That power had better be 5, right? 3 to the 5th equals 3 to the 5th. I would sure hope, right? Now, it's not always that easy, but if they are the same base, you can basically cancel them out. So I do cancel them out. I end up getting 4x equals 12, and then you solve this just like any other equation, and you get x to be 3. Now, for some of you, that solving of that 4x equals 12 is going to be a tricky part, but that shouldn't be the hard part for these problems. The hard part for these problems is, what do you do when the bases are not the same? So over here, we have 5 to the x minus 1 equals 1. Okay, this is not 5 to the 3rd or something like that, where I said x minus 1 equals 3. So how do I make this the same base? Now, some of them are a little bit more obvious, like this 1/4. I can see a 4 there. Still got to figure out how to put it up to the top. But over here, what in the world? So the question is really, I have to replace this 1 with 5 to some power. So what's power, does x have to be to make this true? Well, might have to go back to watch the last video, but it's 0. So 5 to the x minus 1 equals 5 to the 0. Now that we realize that 1 is 5 to the 0, it's almost like a trick. It's not really a trick, it's something we should know. Now we can cancel these out, and we're going to set x minus 1 equals 0, move the 1 over, and you get x equal to 1. And if I plug in 1 here, 1 minus 1 is 0, 5 to 0 equals 1. Everything checks out. Okay, now I'm going to go from problem to problem most of the time. If at any point you need to just sit there and look at it or finish up, pause me, okay? Because we have all the time we want in these problems. Alright, next one. So how do I make this 4 to something equals 4 to something, right? So the left side is already 4 to the 3x. Now over here, I need to make this 4 to the power. But this 4 is at the bottom. So if I bring it up to the top, it becomes a negative 1 exponent. So 4 to the first and the bottom becomes 4 to the negative 1 on top. Now I know we don't usually like that. Actually, if we have our answer this way, we usually like to write it like 1 over 4. However, now that we do have it up top, I can cancel out these bases. I got 3x equal to negative 1. Divide by 3. I got x equal to negative 1/3. Now, if you don't believe this, and again, you can always type in your calculator 4 raised to the 3 times negative 1/3. Let's see if you get 1/4 or 0.25. It should work. Now, that problem is tricky because we need our negative exponent to make it work. Some of these other ones are tricky because they're not the same base. This is a 2 on this side, but this is a 4. Now I will tell you, it's always easier to make the larger ones smaller. So this is 2 to the negative 4x. But what is 4 really but 2 squared? That right there is going to take a little bit of practice for you to get used to. We need to make them the same base. So what's the possible bases? I can't make this anything. So if the question was 2 to the negative 4x equals 5, I can't make the 5 become 2. I just can't. It has to be a power of 2. So some of these problems are kind of staged. There's a way of solving this if it's not a 4 or an 8 or a 16, some power of 2. But right now, we do not have those skills. So cancel out the 2's, and you get x to be, if we divide by negative 4, right? To be negative 1/2. Alright, So let's try some methods. So what in the world do we do here? So I'm going to say get d6 or get whatever base it is alone. So we get this 2 here. We're going to get rid of that. 72 divided by 2 is 36. Equals 6 to the 5x minus 2. Now that we get rid of the 2, this might make it a little bit easier to see. 36 is really 6 squared. And once they are the same base, we can cancel them out. Add the 2 over. And I might be running off the screen here. It's hard for me to tell because I can see it still. So 5x equals 4. I get x to be 4 divided by 5. Alright, so what are the rules of exponents we know? If we multiply, what do we do with our exponents? We add them. So this becomes 4 to the 3x equals 4 to the, I'm going to distribute this negative here because it's just annoying to look at. Once you have that, we can cancel out our 4's, and we get 3x equals negative x plus 8. We've got x's on both sides, so we're going to move them to the same side, add over the negative x. And we get 4x equals 8. Divide by 4. And you get x to be 2. Alright, last one here is probably the trickiest one on the page. So we get a 3 to the 4x plus 12. Just getting rid of the distributive property here. Equals. And I said we always want to mess with the larger of the two. So how do I make a 9 become a 3? Well, 9 really is just 3 squared. So that's the 9. 9 is 3 squared. Everybody knows it. I sure hope you do, because it's 3 times 3. And the trick here is, well, other than realizing that 3 squared is 9, then we have an exponent to an exponent, which means we're going to multiply them. So 3 to the 4x plus 12 equals 3 to the 6x. Now we can cancel these out. We're going to subtract 4x over. We get 12 equal to 2x. So x should equal 6 once we divide it by 2. Whew. Alright, let's see, is there anything else? I can only see what I can see on the screen here, right at this point. But what I'm going to say for the problems I got so far here is, you got really this goal in mind. You need the bases to be the same. You want 4 to the power equal to 4 to the power. If they're already like that, like they are in the first couple ones, you can cancel out the bases and just solve the powers. If they're not like that, then the goal is to get it to be like that. Again, it's not always going to be possible. And once we're past that, we need logarithms and all that fun stuff, which is not generally something that you want to worry about as a freshman class. Always ask me, I'm happy to share, but right now we're going to solve the easy ones. Okay, is there anything else we're going to talk about today? We got some word problems. Okay, so the word problems here, I shouldn't be too bad. You just got to really read them well and understand what you're looking at. And that's the key to all word problems. So we got CD sales, I can't talk, are exponentially decaying based on this equation. Okay, you don't need to know what exponential decay is. You just need to know that this is an equation. P is the amount of profit. Okay, that makes sense for P. And T is the number in months from now. Okay, so T is months from now. Okay, what's the company's profit this month? Alright, so the question is, how many months from now is this month? So what I would say is T equals 0, and you might be able to argue for 1, but months from now is this month? I don't think it's any months. So what do we get? We get P equals 2,000 times 1/2 the 0.25, but we just said T was 0, so in this equation here I'm going to replace T with 0. 0.25 times 0 had better be 0. Ooh. 2,000 is 1/2 to the 0. Anything to the 0 power is 1, but only this chunk, and that's 2,000. So it's 2,000 times 1, and please do not tell me 2,001. So it's 2,000 It doesn't say it's dollars. It could be thousands of dollars. It could be pounds. I don't know. English pounds, not weight. But anyway, what will the company's profit be in a year from now? So we get 2,000. It's 1/2 to the 0.25 a year. Okay, so a year is generally going to be 12 months. Sounds good. Now, this is where a lot of you will take out your calculator. I'm a little lazy. My calculator's kind of a little hidden on this computer, so I'm just going to go like this. 1/2. It's a quarter of 12, because 0.25 is a quarter. So a quarter of 12 would be 3. And what does this mean? We're going to take 2,000, we're going to multiply it by 1/2 3 times, right? Let's see, can we do this in our head? What's 1/2 of 2,000? It's 1,000, right? What's 1/2 of 1,000? 500, right? Well, we still have another half to do, right? So we should get 250. So that's doing this problem in our heads. Now, like I said, my calculator's a little hard to get at, but I don't, screw that right back. Don't really want not to get at my calculator. So I'm going to try to type this. I'm going to show you how to type this in the calculator. Jeez, that was terrible. I type this in the calculator, straightforward. Okay, so if we take out our handy dandy calculator, which of course everything goes away whenever I write that, we're going to write down 2,000. Parentheses 1 divided by 2 for 1/2, raised to the. Now the new calculators, you get, it goes up as a power, and you can write it just the way you see it. 0.25 times 12, and we'll see if I'm just being stupid, but no, hey, it's wonderful, it's 250. Now if you got an older calculator, here, I'm just going to say it. If you get an older calculator that doesn't raise the power up like this, what you got to do is put parentheses around it. So here, I will go. I'll just talk about it. I got time to do it. So if you get a newer calculator and that worked out just fine for you, then I got nothing else for you in this video. But if things didn't work out so well for you in your calculator, let me show you what might be the issue. You gotta go to Classic here, and it looks like this. 2,000. This is a whole lot harder to do than this. Parentheses 1 divided by 2. There's a difference. On the old calculator, put the raise to button. It doesn't actually raise it up. You have to put parentheses around it. 0.25 times 12. If you do it that way, your life will be just fine. What a lot of people tend to do is they tend to do this. They forget to put the stupid parentheses on here. And they do 0.25 times 12 with no parentheses whatsoever. Once it's telling the calculators, you're taking 1/2, raised it to 0.25, and then that times 12 is just completely separate. And you end up with more profit instead of less profit. So, all word problems really hinge on the question of, do you understand what I'm trying to ask you? So take your time reading the problem. Don't just glance over them and find the equation and then try to answer it. Like, really try to understand what's going on with the problem. Alright, so that's it for this target. Good luck. Try to get the bases to be the same, and then you can solve them.